Hi, thanks for watching. The purpose of today's video lesson is to demonstrate the power of using graphs to help reason out when you have to do some complicated algebra. Now the example that I'm using isn't necessarily reference to what my class is working on right now, but it definitely highlights the point I wanted to make in a pretty decent way. So let me back up here. This is the equation that I need to solve. The square root of x minus 3 equals 1 minus a half x. Now, why do I need to solve that? Well, let's not ask these kinds of questions. But this is look at it as a thought experiment. What happens if you are asked to solve an equation in this kind of form? Well, what we need to do is square both sides. But before I do that, I don't like fractions, so I'm going to double both sides. And now I'm going to square both sides. Remember, squaring the left-hand side, I'm going to square, it's going to be basically 2 times the square root of x minus 3 times 2 times the square root of x minus 3. So we're going to have a 4, and we can get rid of the square root by having the square root of x minus 3 squared. On the right side, square that, we have to remember that 4-letter F word, FOIL. So don't forget you're going to have that extra minus 4x involved. Anyway, as I continue to solve this equation, I recognize it's going to be quadratic, so I need to set it equal to 0 so that I could use the zero product rule. And in so doing, actually I use the square root of both sides here, but same difference. I end up finding that x equals 4 is the only solution to this equation. So most people would be satisfied with the work that I did. I reasoned it through. However, I'm the kind of person who believes we shouldn't be answering questions without making sure that we answered correctly. So is this value the only value that makes this equation true? This equation right here. So I put 4 in and I get the square root of 1, and on the right hand side I put 4 in and I get 1 minus 2, and it turns out 1 and negative 1 are not in fact the same number. This actually has no solution. So this is the way I learned algebra, and this is the way I learned how to solve equations. And with the advent of the graphing calculator, some advances were made in the approaches to solving equations that I wish would have been around in my day. This is all you have to do to solve that same equation. I want to write the equation over here and paste that here so you can see. If I had to solve this equation, all I really have to do is take a square root graph and move it to the right 3. 1, 2, 3, square root graph. It's a sideways parabola. To graph the line, I have the y-intercept of 1, and then I go down 1 over 2, down 1 over 2, and I get the line, and clearly you can see there is no solution. So all this algebra is a bunch of smoke and mirrors, which got me to the place that I could have gotten to if I just had one quick little visual perception of the left and right-hand sides of this equation as functions. So what I'm trying to get at really pertains to what my class is working on right now, which is solving absolute value equations. This particular equation that I want to look at is when I have the absolute value on both sides of the equal side. Now, I don't want you to get too hung up on the nuts and bolts here, but just bear with me as I just walk you through this, because basically I have to get rid of this absolute value, which means I have to consider both the positive and negative alternatives of the innards, of the guts. Because if this stuff is positive, like when x is 7, this is going to be positive, I just leave the 7 alone to get rid of the absolute value. So in one situation, I will get rid of the absolute value and just leave everything alone. On the other hand, x could be 2. 2 minus 4 is negative, and in order to take the absolute value, I have to take the opposite of negative 2. So for those situations, I'm going to show the opposite of x and the opposite of negative 4, showing the opposite of everything inside the guts. And over on the right-hand side, I just left it alone right now. It's 2 minus 1/2 absolute value of x plus 3, and 2 minus 1/2 absolute value of x minus 3. But of course, I have to get rid of the absolute values on the right-hand side. So using the same logic, I have one situation where I remove the absolute value, leave it alone, and another situation where I remove the absolute value but take the opposite of the guts. But I have to do that over here too, which means I have 4 equations to solve in order to get this double absolute value solved. I double both sides. Now, don't get this is where I said don't get hung up. You're gonna have to trust me on my algebra here. It's just basic algebra 1 kind of stuff here, so I trust you can figure it out if you had enough time. Anyway, I ended up with 4 solutions for x. So 4 different numbers that might make this equation true. Just to verify, though, I'm going to let x equal 3, put that into my equation. 3 minus 4 is -1. Absolute value of -1 is 1. And over here I get half of 6, which is 3, and 2 minus 3 is -1. That's not true. So x equals 3 is a fake solution. All of this is just lies, BS. Well, over here I have x equals 15. That was one of my other solutions. I put that in. I get 11 on one side, and 2 minus half of 18, which is -7. Also not true. So 15 is BS. Well, maybe this whole thing here was the wrong setup. Maybe this is the stuff that's going to make it true. I spare you all the numeracy here, and just to point out that all 4 of these are not, in fact, solutions to the equation. You might be doubting my algebra because I sped you through it like I'm trying to trick you, like I lied or something. But the truth is that this equation has no solution. And all of this algebra is just smoke and mirrors, just trying to make you think that there is. And if you were a meticulous enough student, well, you got a page full of algebra, all to end up with a null set. There's nothing here. Let's take a graphical approach instead. You'll see I just had 3 points graphed immaculately. That's for absolute value of x minus 4. That's an absolute value graph, that slope of -1 to 1. That's shifted to the right 4. So I go over 4, and then I just go over 4, up 4, make a point, and I have a y-intercept of 4, because the absolute value of -4, and boom, I got the absolute value. That represents the one side of the equation. The other one's a little trickier. There's a vertical shift up 2, and there's a shift left 3. So I got a new origin where I go left 3, up 2. The rest is slopes are plus or minus a half, and the negative means the absolute value is opening down. So when I draw that graph, suddenly I realize, oh, there's no solution to the equation that I showed you earlier. So you have your alternative, all of this algebra, or learn how to graph. Now, taking time to learn how to graph, obviously that takes time. So the first time you try to use this approach, it's not going to feel like it's any benefit to you. Over time, however, you might be able to see an equation like this one, like this equation right here, and visualize over 4, little v thing, and this one's back and down. I bet you there's no solution. And then you actually put it down on paper, and you're like, sure enough. So just I hope that this gives you some sort of sense of an incentive to why we should think graphically as we do our algebra. Obviously, in order to be college ready, we're going to have to be able to do some algebra skills, and a lot of different skills need to be with us for a long period of time, and so that's why we're learning the algebra approach. But let's learn the algebra in conjunction with geometry, just making a graph. So this is a more moderate, calm kind of a situation, but I want to point out why graphing is good, not just because what if there's no solution? Fact is, you'll most often be asked to find equations that have solutions, not no solutions. But I would just want to, write down the equation here, and just first look at it graphically. The right-hand side, though, I just have to do a couple little bit of gymnastics to make it graphable. So I'm going to rearrange the terms. I'm going to factor out a -2. And then I'm going to pull out the -2 from the absolute value, and then take the absolute value of -2. So this is a transformation or modification of that. You can test me on it. If you put this into Desmos and you put this into Desmos, you're going to get the exact same graph. So that, though, enables me to see that the slopes are going to be plus or minus 2, and that the graph is shifting right 1.5. So I'm going to put 3 points, 1 at 1.5, 0. And then from that point, I'm going to go over 1 unit up 2, and I'm going to go back 1 unit up 2. Swaggity swack, I got my graph. The other one is easy peasy. It's just a leftward shift of your standard absolute value graph. So the slopes are going to be plus or minus 1. So I just move over 1. I've got my V graph, and now I can see that there are 2 solutions to this. Now, if I was to do what I did before, there would be 4 different equations to solve. 2 of them would be lies, and 2 of them would be the truth. But as it stands, if I just recognize that these rays are all linear equations, and I can see that, oh, I got ahead of myself here. I can see that this is the ray x plus 1, and this is 3 because the y-intercept is 3, minus 2x because the slope is negative 2, and this is positive 2x minus 3 because if I extended the line it would cross down here. So, to find the intersection of point A, I don't need to think about all 4 possible equations. I just have to solve 2x minus 3 equals x plus 1. That's super easy. It's x equals 4. And the other one, I don't have to actually guess from the setup what equations to solve. I just take 3 minus 2x equals x plus 1. That's where they intersect, and that's an easy equation to solve as well. So I can check my answer with Desmos and see that they do intersect at 2/3 and x equals 4. So those two values of x make the equation true, and I didn't have to do a lot of extra algebra. Once again, on paper, when you look at all this stuff and how hard it was to make the graphs, you might say it's not worth it. I'll just do all 4 equations and check all 4 solutions. But that kind of defeats the purpose of learning mathematics. We want to learn mathematics for all of its beauty and all of its tools and all of its abilities, and that's why I'm showing you this video. So I know it went a little long, but thank you for watching.